So what are we doing today? Today is a bit of a different topic than my typical live research. Today I'm going to be taking a look at an idea that I've been sort of like entertaining for a while, which is like I've been doing all this kind of playing with the idea of like raw videos and raw kind of like raw research, like how do you capture that like honest and oh guys, give me a second, someone's at the door. Yes. No. Vale, papá. Cool. So oh, sorry, I gotta switch the scene back. There you go. Cool. So what I was gonna say that yeah, I've been playing with this idea of doing all this kind of like raw video and stuff like that, right? I mean, ultimately, why is this useful? It's a good exercise. I think it's a good thing. It's an interesting experience for myself as well. Um, but then I also kind of realized that it might be useful for something else. It might be useful to actually kind of train an AI in the future, like kind of use that as training data, right? As in like raw data of like some, kind of showing machine what learning and sort of research truly looks like. I mean, I don't know. Essentially, it's interesting, right? Because one could think about like what is it that makes something um, conscious, smart, human, whatever it is, right? But like, how do we learn this stuff? I mean, and if you take a look at things like this GPT-3 story and all this kind of stuff, you do end up thinking like, maybe all that really is there is it's a language model, right? In a way, like it's a sort of a symbolic way of understanding the world. I mean, that's what we do even when we think, right? It's just in our heads. It's still language, but it's in our heads. And watching kids grow is and explore the world it's a super interesting experience to kind of that actually kind of in a way reinforces that view on consciousness. Just seeing how like a child just actually tries to understand things, but just kind of like imitating, uh, what they perceive, what they kind of see, right? It's like it's really interesting. I mean, there's of course everything that goes into like learning how to build how to kind of like operate our body, but then sort of the interaction with the world is like the language and how do you think and stuff like that. It's just super interesting. But anyway, it's one of the things where it's like, well, how do we learn to learn, right? Like we learn this by essentially seeing others do that, essentially kind of searching for things. And when we think about, okay, how do I learn about a complex how do I learn about a complex problem? How do I learn about something? Well, you look for someone to teach it to you. I mean, that's kind of one way to do things, right? So you kind of, you're looking to be trained in a way, right? So you're looking for some material that you can just go through, that you can process, whether it's text, video, whatever it is, so that you can basically adapt your model, right? And so this is like this is what learning is in a way. But then you kind of sometimes think about like, cool, so what is then self-learning when you're not really, I mean, essentially, there's not really like self-learning. Self-learning. This is interesting, right? How do you come up with your own conclusions, or how do you kind of do research? Is interesting because in a way, it's like you're not really, it's like unsupervised learning in a way, right? So or the classical traditional learning is like you're basically doing in supervised learning in a way, right? So I mean, let me just am I saying bullshit or not? Let me just can I just start an incognito one and just like supervised learning? I think this is what, when you're providing data with this to a system and you're actually telling and you're actually telling the system. Also known as supervised machine learning, is a subcategory of machine learning. It is defined by its use of labeled data sets. So you're actually basically telling the system what is the correct answer, just many times. And that is just, that is how a lot of the, human teaching works as well, right? You just assume what the teacher is telling you, or what the materially that you're looking at is telling you. You're just assume that the labels are correct. And so you just, you just gonna go through these. But then unsupervised learning is when you have that you have that kind of just raw data. There's like no there's no guidance in terms of whether something is correct or incorrect. You just kind of so the hope is that through mimicry, which is an important mode of learning in people, the machine is forced to build compact internal representations of its world and then generate imaginative content from it. Within a stacked exhibit self-organization that captures patterns as probability densities or combination of null feature preferences, the other levels of supervision spectrum. So this is essentially, I guess, something that you could use from as a dichotomy between sort of research and actually learning. Research is when you're kind of, you've got some basics, some base knowledge, but then you're trying to learn something new on your, or discover something new on your own. You're not just like, you just don't stumble upon these on the world. You try to understand, make sense of data, do experiments, do whatever research stuff, search for things, right? And so in a way, but even if you're relying on existing things, like let's say I want to learn quantum mechanics, or I want to learn about quantum mechanics. It's kind of like you have knowledge there that you can use for sort of learning stuff in a supervised way, right? But still, like I guess one way of doing that is a bit of that kind of mixture of you're getting things and then you're trying to discover things yourself in an unsupervised way. I don't know how to explain that. I have the feeling that there's this kind of dual mode of learning, in a way. You kind of have you have the stuff that's the body of knowledge that exists out there, and Wikipedia is a great example. But then you kind of have that, like, okay, so let's try to discover, or let's try to answer this question without actually finding, well, it's actually understanding it, right? Like, how do you build the understanding, right? Like, give an example. Is like, how do I learn what a Fourier transform is? Well, I can go and look up the answer, but it's when it comes to this kind of topics, the answer is, there's no just unique answer like one liner or something, right? It's just that there's a bunch of things around a concept that you kind of have to discover if you want to understand the first principles of it, and that you can then apply later on. So essentially, this is what I'm exploring with the whole uncertain systems, right? So how do we learn this kind of stuff? How does it look like, this process? Kind of exploring this a little bit, and then with a very specific instantiation of the problem, which is quantum mechanics. But in general, I guess that applies to everything. So one of the things that I've been entertaining in my head for the past months is why, if we just kind of build a huge body of these kind of data, it will be, you build a great data set to kind of teach a machine how to do that, how to actually how to actually teach itself in a sort of in this kind of mixed mode, like supervised unsupervised way, right? And so, I thought, why not like encourage other people to do that? And that would be a great idea, sort of a bit of a little Web3 project where you kind of have a contract, sort of a smart contract or something, and you would upload, say, a video or a document or a tweet, whatever it is, like whatever it is that you've used to capture that raw process uh, around a specific, and it doesn't have to be self-contained, like it's going to show you exploring stuff, right? Or it's going to show how do you explore, whatever it is that you're exploring, and capture that, and then basically, give it to the contract, and then the contract will kind of give you, you know sort of coins in exchange or something like that, like whatever it is, like a made up, knowledge currency or something like that. And of course, that the idea is to use this kind of like blockchain Web3 economical model where these coins would allow, will kind of build up intrinsic value in a way, would allow you to do other stuff. I don't know. And I just kind of wanted to play with these, especially because I've recently discovered Replit as I was building, or playing with, some of the SymPy stuff, and I kind of came across these the other day, where basically apparently there's a really easy way to build smart contracts and test them and play with these within Replit. So I think it would be great, because I'm a lazy person, and that is basically a lot of the stuff that is difficult about Web3 is how to get all that infrastructure ready in terms of like how do you build a contract, how to deploy stuff. And I'm talking about playing with some very sort of, the prototype would be very simple. I don't even care about like upload. It's more like I'd assume you have you kind of connect your wallet, and then you basically give the thing a an IPFS link, an interplanetary file system link, and so I kind of assume you've uploaded whatever it is already in the IPFS peer-to-peer network, and you just give it to the contract, and then the contract gives you some kind of currency in exchange. Of course, the question is, what? How do you make sure? So that's just a folder. I don't. What is these? And then of course, I think these are just examples. I hadn't seen that before. Can I just delete these folders? Oh, actually, I did try something a while ago, but I forgot that it was in here. What is that? Is that an example on Solidity? But yeah, so basically, I mean, there's still the problem of like, how would you validate that I'm not just uploading like a cat video or something? So you'd still need a human. You'd still need a human to do that in a way. So you depend on someone else. Would need to incentivize someone else to actually maybe validate your. Yeah, that seems to be examples, token, simple token, wallet, simple wallet, NFT. So there's some examples. Give me a second, I'll be back in a second. Sorry, I had to run to the door again. Oh god, I should exercise a bit more. Anyway, essentially that's kind of what I had in mind. So basically build that contract and yeah, kind of encourage people to just, you know, upload the video. So upload the content, upload the stuff, get the coins as a reward, and you know, by sort of hoping that by doing these, we encourage more people, especially professional researchers, for example, to, you know, kind of upload their own, you know, their own ways of doing things, their own ways of doing research. Yeah. Oh, I need to go for some water, and then we'll get started with the coding. I mean, we'll see. My goal for these is try to spend the next 20 minutes, half an hour or so, and trying to kind of understand how can I do that in Replit. Should I just go and create something? Solidity starter, and I'll just call it probably call it ANSYS. The call is like ANSYS or something. ANSYS coin, or whatever, I don't know. As always, naming is the most complicated. Since when is ANSYS Columnar? I'll just call ANSYS coin, and then see what happens. Gonna get something to drink and be back in a second. Cool. So what do we have here? Yeah, it feels, I think that's exactly the same I had in the other folder. Did I delete that? Just want to make sure I have stuff clean. So I have these folders here. Can I just delete these and then delete these? Yeah. And can I just delete? Oh, the folder stops existing. Okay, ANSYS going. Cool. We have here tools. So welcome to the world of Ethereum, Web3. Oh, sorry. Here's better, easier to read. What is that? Whatever. So press the run button. You should only need to do this once and might take like 15 seconds to install. Okay, so this will installs everything. Replit's really cool, but I have to still get used to like how does this actually work. Like you hit the run button and it actually, what is it that it's running? README contract, simple storage, package files. Those are all the dependencies. Interesting. Whoa, 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 whoa. It actually opens up some kind of UI. That's cool. page. Ooh. So I actually can connect a wallet, deploy contracts. Interesting. Okay. Yeah, but I want to see. I want to kind of open this thing here. How can I? Okay, actually. Okay, it just runs it like that. No, this is the REMI one. Okay. So you should only need to do this once, and might install the run tools and start up the contract the contract deployment UI and compile your contract sol file. Okay, so that well, so this will automatically compile whenever you edit it, and all your contracts inside of this file will be available to deploy from the UI. Pressing Control S will reload the UI. We have pre-installed packages from OpenZeppelin contracts. To install other Solidity packages that are distributed on NPM, make sure you install them using the package installer in the sidebar. I think that's here. Cool. Examples, we include a few example contracts in the examples folder. This will not be automatically deployed or accessible in the UI, but you can copy paste them into your main contract sol or import them. They're there for you to reference future work. Okay. Cool. LSP support. I don't know what LSP is. Is it linting? Integration with Hardhat for local in-REPL testing. An actual Solidity route to quick prototyping. Testing functions or lines. Feedback. Okay, cool. Seems. Yeah, but how do you deploy contracts? Do I actually have to connect my wallet? Like, how do I test without, like, can I test in a sort of a dummy network or something like that? Because that would be definitely the best, right? I don't want to start deploying things on Ethereum and just pay all the money for nothing. I'll get 1 ETH for testing. So there's some actual testing stuff that you can do. Ethereum mainnet. Let's see what happens. So what if I connect the wallet? Oh, sorry guys. Why it's in German? I don't want to. What I don't want to do is because I'm not in incognito mode. Let me just move that away from the screen here. See if I can just reconnect, because I already have a wallet, but so give me a second, okay, because I have to figure this out. You know, just in case. I mean, I in this wallet I just have probably like 0.01 ETH or something, so not a big deal. But maybe I'll just put the be right back screen just in case, and because I when I installed that I did not connect my wallet again, so I'll do that in a second. I'm still here. Hopefully you can hear me, but what I need to do is I need to actually find the you know, I have stored my key phrase in a super ultra secret way in place. It's so secret I can't remember where. here maybe. Come on. Or wait. Maybe they are here. So let's see if I imported the right have I imported the right? It looks like, yeah. Okay, cool. So now, so I have 0.02 ETH in this wallet. $70 currently that is. And I have another wallet, but I don't know what's in there. Anyway, back in here. So what if I connect the wallet now? What will happen? Will it, okay, so that's the account, right? And I want to connect it with this account. Connected. Okay, cool. So 0.02 ETH I have here. That's my address. Okay, so I can switch to a test network. And I can use this one. This is pretty cool. Replit testnet. So Replit gives me a fucking testnet. Like, that's nice. So I can get an ETH for testing. Okay, so with these I can actually deploy contracts. That's cool. Okay. Now that I have the wallet connected, I can choose the contract and actually deploy it. So what do we have here? So we have contract simple storage, and then we have a math test. And we have examples. What have I done here? Examples, NFT token. I think it's token is what I want, right? Because that I want, basically I want to kind of have so this, okay, so so that's it's an Ethereum example, and so basically I don't know, I hope you guys can read that because I don't want to zoom in too much because then my stuff gets messed up in here. But maybe I'll just no, can't I hide these? No, I can't. Yeah, maybe I'll actually exactly, I'll do that and close it here. So I have these. Oh, and I have to connect the wallet again. Yeah, let me connect. That's not Coinbase. I know, Coinbase. I want to connect that one, and I want to switch to a test network. I'm okay. I'm not in mainnet, right? Because I don't have an ETH. Let me just refresh that. Connect. Okay. Whatever. I have an ETH, so I'm because I don't have an ETH in real life, so I assume that I'm on the test. That's wrong. I'm assuming it's probably a bug, but anyway, cool. So this way I can just kind of, you know, get rid of these for a second and focus on that. So this is okay. So an address is comparable to an email address. Okay, so blah blah blah. So I have, so there's a token supply, Um, I mean, again, this token wouldn't really have a supply, right? Uh, because in a way, it's just you want to reward people for uploading the stuff. But I mean, it feels somehow uncomfortable. Like if all you need is if all you need is a video to get that, like a coin without supply doesn't sound like a great idea. But let's ignore that for a second. So here it's basically you map the balances. Okay, so you get the addresses and you see how many yeah, basically. And then the constructor. Okay, so the deploying, the owner is is the person who deploys the contract, and then it set the token balance of the owner to the total token supply. So the owner has all the supply, and then sends an amount of tokens from any caller to any address. So basically this method okay, so requires blah blah blah, and then what it does is it takes the amount from here and adds it here. So what this does is, I guess it's just a contract where I can send, or anyone can send any money to anyone, right? There's no, I could of course require that the sender is the owner, so only the owner can actually send the stuff. But that's not the, I guess that's not the point, but that's good basics, a good basis. And then wallet, what is the wallet doing? So you have an owner, lock deposit, lock withdrawal. Withdraw. Okay, so only the owner of this wallet can withdraw. So the sender must equal the owner, and then the balance must be there. Recipient transfer. What? That is what is these doing? There are events. Events allow for logging of activity on the blockchain. Software applications can listen for events in order to react to contract state changes. Ah, interesting. I didn't know that. What is address payable? Recipient. Boo, there's a lot of stuff that I didn't know about that. Payable. Solidity. Its modifier allows the function to receive ether. Okay, there's definitely quite some stuff that I need to learn. Yeah, but that will be an NFT, simple NFT. Whoa, what is that? Ownable token counter. Okay, so whatever this is, I don't know, what is that? Is it some sort of kind of standard or something? It's the non-fungible token standard. Okay, so it introduces a standard for NFT. In other words, it's this type of token is unique and can have different value than another token from the same smart contract, maybe due to its age, rarity, or even something else like its visual. wait, visual. Yeah, as long as it's have a variable called token ID. So for any contract, the pair contract address ID must be globally unique. That said, a dApp can have a converter that uses the token ID as input and outputs an image of something cool like zombies, weapons, skills, or amazing kitties. Okay, yeah. Okay, so that's just an NFT standard, the NFT standard thing. And minting is essentially creating an NFT. So who opens it? What is the tokens URI, which is a link to an image hosted on IPFS. And then okay, so that is already cool. So that is already all built into the standard. So there's sort of a mint function that puts it into the blockchain. You set the, that's pretty easy. Okay, so there's a lot of stuff that's been done already. Cool, but what do we need? I mean, let's think about these. What do we... Because I'm like... So I am torn between two ideas, right? So one is that experience that you're uploading, you know, you turn it into an NFT, because essentially that's what it is. It's a it's sort of a unique experience, right? So that's what it actually is. But then what's the value, right? So you mean that, and then why would someone buy this? Well, someone will buy that as in, you know, you could buy NFTs just because, but yeah, the thing is, you know, it would make sense that you kind of like turn special moments in NFTs. Like, for example, let's imagine that, you know, a researcher kind of goes and, like, you know, this sort of creates a new theory of everything that it turns out to be, you know, that one, right? So the actual thing, and then captures that into a video, and then, you know, it NFTs the video. But then for these we have already NFTs, right? So why would you you know, what would you encourage? You want to encourage people to kind of upload all the raw data, not just like, oh, that is kind of what led to that moment, right? That kind of aha moment, so to say. So you want to encourage people to just, well, do that. So in a way, you want a token, right? You want to give people, I really think you want a token, because you want to basically give people something in exchange for the video, right? So I would start with these simple storage, stored data. Okay, so actually the contract has memory. You know, you just can have memory, and they can store things and blah blah blah, right? But let's just ignore these. Let's just let's just use that contract as a basis and say, well, it's the ANSYS token. And so, yeah, well, it is the owner. You know, yeah, you have the owner. The owner, it's going to be me, because I'm going to deploy the contract. So I don't know about token supply. What I do want to have is a mapping between, so it's the balances, and then I also want to keep I basically also want to store. Do I wanna keep ownership in terms of like track of ownership of like who uploaded certain things? Probably not. Like nobody cares. So in a way, you wanna have probably would have just like removed, right? Stored data. That's okay. So I can declare whatever I want. Can I declare Okay, so can I just say, well, I want to keep track of the balances. Do I want to keep? Yes, right, because essentially that's the coin. Otherwise, how does this work though? Really? Like the smart contract needs to keep track on who's how much of a token someone has, then how the wallets actually work? Like, do wallets have the lock deposit, lock withdrawal? How do you get a wallet to how do you get a token to be recognized? How does a token get recognized by? How does a token? Because I think the wallets really just do these. I think that's the fun thing, is like the wallets actually just lock deposits and withdrawals. Send ETH from the function color to the simple wallet contract. Your own token. I guess there's a bunch of services that allow you to do things like that. I make my own. Okay. So awesome. Okay. Open MetaMask and click on the Add Token button, select the Custom Token option, and paste the contract's address in the first field. Oh, okay. So basically, we'll fetch the token symbol and decimals automatically. Click on Next, and your token will be added to the wallet. It will be available under the Assets section in MetaMask. Okay, so first of all, but this is, okay, so there's a standard for these. I guess what this means is it ensures there are certain functions that I need to implement. There we go. Yeah. Using contracts, we can easily create our own contract, which will be used to track gold, an internal currency in a hypothetical game. So, okay, so you import stuff like that. Okay, but I guess if I want to import things, do I have to? This is importing stuff like that, and do I have to? Packages. Do I have to actually install it like that? Doesn't find it, or what? Shouldn't it find it automatically? No. Okay. How often user inheritance, and we're using for both basic standard implementation and the name, symbol, and decimals. Okay, so this basically ensures that it has. So we'll actually go with these. So we will just go with these actually. It's going to be ANSYS token. Oh, actually, do I have to does this token need does the so these are the functions. Is the this thing must be like 3 letters, I guess so. The symbol, or can it be whatever? I don't know why people make so much of a fuss out of these. This is just very basic programming, to be honest. There's nothing really special about these, other than like the mental model, I guess. Symbol. Is there any restrictions to the symbol? I'll call these the ANSYS token, and basically the name is ANSYS, and then this is going to be like what? I mean, isn't it? Is there any length symbol? Okay, so there's different. No, there's no restriction, it seems like. Because to be honest, I'll just call it ANSYS, right? Mint initial supply. Oh, so I have to give it an initial supply. Okay, but I guess the supply can increase, right? It would be good to know how that actually works, to be honest. But okay, what is it doing? So you deploy the deployer's balance. So there are different supply mechanisms. Okay, let's do that. It's funny because what is that? What is OpenZeppelin? What is OpenZeppelin? I guess you can just create. Okay, it looks like a place where you can just create your contracts and stuff like that. Complete suite of security products to build, manage, and inspect all the software development divisions, Ethereum projects. Okay, yeah, that might be an interesting thing to consider at some point. But where was I? So in this guide, you'll learn how to create an ERC20 token with a custom supply mechanism. We'll showcase 2 automatic ways to use OpenZeppelin contracts. Okay, but I don't want to specifically use OpenZeppelin stuff in here. Cool. Yeah, sure, of course. Those will be the miners, right? So the people actually providing the videos, because it's like you're kind of, you know, working. Yeah, that's actually cool. Okay, modularizing the mechanism. But I'm afraid this is OpenZeppelin specific, so. This is from ethereum.org. So maybe that's better. Emerged as the technical standard used on smart contract Ethereum blockchain for fungible token implementations. Defines a common list of rules that all fungible Ethereum tokens should adhere to. Consequently, these tokens standard empowers developers to full-time predict how new tokens will function within the larger Ethereum system. This simplifies these developers' tasks because they can proceed with their work knowing that each and every new project won't need to be redone every time a new token is released. Cool. So okay, so these are the functions. So total supply, balance off. Okay, so yeah, that's what wallets are using probably, right? So that's what wallets are using to kind of query the balance of someone. Allowance, transfer, approve, transfer from, transfer approval. Total supply returns the amount of tokens in existence. This function is a getter and does not modify the state of the contract. Keep in mind that there are no floats in Solidity, therefore most tokens adopt 18 decimals and will return the total supply and other results as followed for one token. Okay. Not every token has 18 decimals, and this is something you really need to watch for when dealing with tokens. Returns the amount of tokens owned by an address. This getter returns the remaining number of tokens the spender will be allowed to spend on behalf of the owner. This function is a getter and does not modify functions. Moves the amount from one address to another. Events. This event is emitted when the amount of tokens is sent from the from address to the to address. It's about code to base your from show wall. Ah, okay, so that is, yeah, okay. Ah, so OpenZeppelin has a good implementation as well. Total supply. Okay, so actually this has a total supply. Decimals, 10 ether. Why is an ether? It's just an example, I guess. And OpenZeppelin has another symbol, total supply. Balance off. Okay, so everything is well, I mean, I can just copy paste that. And to be honest, I just need to add probably, okay, so supply mechanism has to be added in a derived contract, using Mint. For generate mechanism C, okay. So that will probably just take me where I came from. But I like that. So I can implement a supply mechanism using Mint. And I think I'll just use that. Copy. So I think I'll just use that. Basically, and say cool, so 0.2, but whatever it is. So string private symbol. Okay, so I in constructor. The default value of Ethereum key to select different value. All are immutable. They can only be set once during construction. Okay. And how do I call the constructor? What I call the constructor when I deployed, or returns the name of the content of the symbol, decimals, total supply. Where is mint in here though? Function mint. So creates amount tokens and assigns them to an account, increasing the total. Okay, so that increases the total supply. That's okay. That's interesting. So emits a transfer with from set to the zero address. Cannot be the zero address. So that's okay. The zero account, the zero address is my address, I guess. And so it increases total supply. Okay. Okay. So this means that I am then, I can then just add more supply. Okay, but it actually does have these. So what is it that it's missing in here? What am I doing? So there is a am I stupid? That's the link probably. How do I the mechanisms? Okay. Okay, I probably want to read about these calmly and then do that. Yeah, but I think I'll probably go with something like that. So it seems like I thought these was already included in here. I mean, you have the min function that adds total supply, burn, basically burn supply, approve. So what is this doing? This is okay, the thing with the spending, whatever. I have to go through this. Okay, but that's good, probably a good basis. What is this? Is this just dead? Connect the wallet. Okay, so there's parse resource not found. Oh, so I actually have to import that probably. I just have to import. Yeah, I have to import these, I guess. Okay, so I'll get that sorted out next time. But yeah, let's do that. Essentially, and I guess all I'm missing here is to basically do I need to yeah, I need to keep track, right? I want to keep track of sort of the uploaded videos, right? I need to keep track of that. And then because essentially that's basically the I'm gonna be giving yeah, to be honest, I don't know, do I need to keep track of it in this contract? Because maybe that's just the minting. It's basically the supply. It's basically the supply mechanism. Do I want to kind of have a supply that I just kind of give out, or do I just want to say, look, every time someone basically uploads a video, I'm gonna mint. So I'm gonna I mean, and can keep it to videos, I guess, but because I don't know, is there a way to define the value of a specific thing? It can be a long, it can be short, it can be like the amount of I guess it's just raw data, right? It doesn't matter what the size is because it does not determine the value of it necessarily. So maybe there's just a standard way to do that, and then I would just kind of do the upload, but I should probably keep the list somewhere because I then essentially I want another set of users to then basically say, cool, go in and check, is that really it or isn't it? Like, is that really a valid video, or is it just like a cat video, right? And how to make sure though that that's not, that's the approval mechanism. It's what's gonna be tricky to keep it decentralized. But yeah, if that's the case, then you get the coins, and then you go ahead. What can you do with these coins? I don't know. I'll have to think about these. But I think that's an interesting idea. Basically, yeah. I don't know. Let's see. And then encourage more people to do that, right? And kind of collect that the database of raw data that can potentially be used to train some sort of artificial intelligence in the future. I hope so, I guess. Cool. Then see you next time.